All right, and since we're going to reflect this triangle ABC over the line, the y-axis, I'll label the points since we can. But the y-axis, just in case we were wondering or weren't sure, is the the vertical axis. That's better. This one right here. Okay, so this is the blue line, which is the y-axis, and we know that a reflection is just going to make all the points the same distance from the line of reflection, but in the opposite direction. So if I'm going to start with A, which I will, I can see that A is to the right here, 1, 2, 3, 4 boxes. So its reflection should be 1, 2, 3, 4 boxes to the left, directly opposite of A. So I'm going to call this, it's not A anymore since it's a reflected image. I'm going to call it A prime. And we'll just go alphabetically through this triangle. So I'm going to go to B next, which is 1 box to the right, which means its reflected point would be 1 box to the left of the line of reflection. Then I would call this B prime. And then finally C, again from the line of reflection, this is 1, 2, 3, 4, 5 boxes to the right. So its reflection will be 1, 2, 3, 4, 5 boxes to the left. 1, 2, 3, 4, 5. Okay? So that would be this point right here, which I will call C prime. Now that I have that, I just need to connect the points. And we'll do that to make the same triangle. So I'm doing that by hand, so it's not perfect, but that'll do. And now we have reflected triangle ABC over the y-axis to get triangle A prime, B prime, C prime, the image. So there's our objective for the day. I can use and identify transformations, translations, rotations, reflections, and dilations. Those are all 4 types of transformations that we've gone over on figures. Now we'll keep in mind today as well that it's composite transformations, which means that we're going to be using, well, today we're just using 2 at a time, not more and not less. So even though some of these can be done with 1 transformation, we're going to be doing with 2. And we'll get started then. But take a minute, copy this down, then we'll get started. So we've gone over this before, and pretty much the transformations are going to remain the same. We have congruent shapes here on the bottom, and then above it we have similar shapes. And we know that similarity is when the shape has been changed in size, but that the sides become proportional. And we're going to need a little bit of that today. So in the past, when we were doing similar shapes, which comes from dilations, let's put that in there, this is for dilations. Dilations will create similarity between shapes, but not congruence. And when we did dilations last time, we were just focused on the ordered pairs. But today, we're going to have to be focusing also on the side lengths being proportional, okay? Which means that if you were to take a shape, let's say you were to take a shape, let's take this shape right here, okay? And let's say that we took the shape and we copied and pasted it, so this would be congruent, right? But what I can do with this shape is I can take it, move it, and expand it, or make it bigger like this, right? Now, proportionality means that if I were to take a side length on this shape, this trapezoid, let's say this side length right here, and I were to compare it to its corresponding side length on the bigger one, and it doesn't matter which one is the image or pre-image, but if I said this was my pre-image and this was my image, then I would see that I'd have to multiply something by this side length to get this side length. But it would be the same for, let's say, the bottom side length right here, which correspond to each other. If I were to compare this green one to the green one, I would multiply the green side length here by the same scale factor in order to get this other green side length as well, okay? All I'm saying is that when you have a dilation, you're going to take a scale factor and multiply all the side lengths by the same scale factor in order to get the new lengths on the image, which we will have to do in some of the problems today. Congruency would be for transformations like translations, translations, but also what we've seen is reflections, and then we've also seen rotations as well. Okay, these three will maintain congruence. The way they're going to describe these, though, so sometimes on the questions they're going to be like, are these congruent? And then we will say yes, so long as only these three have occurred. All right, but what they're going to call these are rigid motions. Rigid motions. Or maybe rigid transformation, I can't remember for sure. But they're going to use this word rigid. Rigid just means that you've taken a shape. So let's take a shape. We'll do a trapezoid again, like this one. Okay, so if I were to take this trapezoid, and let's take right here. So I'm going to copy. I just pasted that, right? So it is congruent because I just copied it and pasted it. But if I were to take it and then move it here, and let's say that even we went as far as reflecting it, like this, okay? Well, if this was the case, this is our pre-image, this is our image. Once again, the sizes of the shapes have not changed, which is why we say they're rigid, because rigid would indicate that, well, the size has not changed. So that would be for a reflection. But like we've seen already as well, you can do this with some kind of rotation too. So if I were to take, we'll do a star again. And let's say I wanted to take this star, maybe I was rotating it about this point way out here, right? So I can rotate the star so that it has the same orientation, but sometimes it won't as well. Okay, so even though I were to take this star and rotate it, let's say right here, or any of these places really, I can, but as I do that, as I rotate this star around that center of rotation, again, the size is not changing as it rotates here. So it is, again, considered a rigid motion. All right? So there you go. So we're going to keep these. Just you're going to have to remember this rigid stuff on the assignment because they're going to bring it up on some of the problems. So composite transformations is where we go through 2 or more transformations at a time. Like I said, today we're only going to be going over 2 at a time. We won't be going over 3, although you could do 3, of course. Maybe even 4 if you really wanted to. You could do as many as you wanted. But we're just doing 2 at a time today. And once again, we see translations, reflections, and rotations here. These are going to keep the size of the shape the same, which is why they will maintain congruence, which we know now they're going to say, in addition to congruence, that is a rigid motion or transformation. This next part, which is important for us, you got reflections. They will change the orientation of the original figure, but reflections, not just reflection, will do that. So we're going to have to add this to the notes, but rotations will as well. So rotations and reflections will change the orientation, just like we saw in that last slide. So these 2 trapezoids are exactly the same size. They've just reflected. So again, I would look at this trapezoid as saying it's pointing upwards. You don't have to, but that's the way I would describe it. And then after it's reflected, now it's pointing downwards. So the orientation has changed. It's not just taking the shape and moving it like we would with a translation. And then a rotation, just like we saw with the star. I guess I'll do a triangle this time. So if I were to take this triangle right here, and let's say I wanted to rotate it around this point right there, which I can do, then we'll see that it does change the orientation as well. Okay, so there we go. Now it's rotating around that instead of rotation. But again, the orientation has changed. It used to be pointing upwards, and then I can rotate it as much as I want, but it will change the orientation right there, okay? So if we see a change, the reason why this is important is because we're looking at some of the figures sometimes, and we just have to determine what type of transformation has taken place. And if we see a change in orientation, pretty much we can eliminate dilations and translations, okay? So part of this assignment is just figuring out what type of transformations have been used. So if we see that orientation has not changed, usually some kind of translation has occurred. If we see that size has changed, then it has to be some kind of dilation. But if we see some change in orientation, we have to have some kind of reflection or rotation to do that. So dilations, of course, if I see a change in size, automatically I would say, I know there's some kind of dilation that has occurred. And we will have to find the scale factor for these, but we'll probably have to use the side lengths of the figures in order to do that. And when we do that, we are not going to use any of the diagonal lengths, because if we did, then we would need the Pythagorean theorem, which we do not want to do as well. Dilations do not change the orientation of the shape, just like translations do not, right? So if I were to take some kind of shape, let's take this shape right here, okay? And let's say that I were to take that and transform it, but let's say that I were to transform it with a translation. Well, if I were to do that with that arrow, I could move it to the right and down, but you see that the orientation is still pointing in the same direction, which is important. Translations also will not change the orientation, nor will dilations, only reflections and rotations. All right, so here's our first problem. Determine a series of transformations that would map figure J onto figure K. Now it's saying figure J onto figure K. So I've seen the graph right there, but before I get to that, it will be important to determine which of the two shapes is the one that you start with, which is the pre-image, and which one you end with, which is the image. Because if you start in the wrong place, you're going to go in the wrong directions, although you may use the same transformations. So it says map or transform figure J, which means that it must be the pre-image. So that's what we're going to start with, and then we're going to map it onto figure K, which then must be our image. Well, that's the figure that we're going to end with. Now, like I said, we are expecting two different transformations in order to make these happen. But which two are going to make it happen? And this is where we got to look at the graph, and this may take some time. As you're looking at these graphs, what kind of transformation has taken place? So I look at these two. What I notice is that the sizes are the same. Okay, so what they're not going to do is make them very close to the same, although they're not also going to make these like where the difference is so small you can't tell the difference. So as long as they look the same, we can assume that they are the same, meaning that they are congruent, okay? So all that means is that I take the pre-image J, and we have to use some kind of rigid motion to make figure K. So for the four transformations that we have, here on the right off the bat here, I can cross out dilations because the size has not changed between the two shapes. So we have dilations crossed out. The orientation has changed, which means I am expecting some kind of reflection and or rotation on this. But what I notice about this figure J is that the change in orientation has just changed or flipped the shape. Okay, so that means that I'm not expecting rotation. If you think about the shape and you were to rotate it in any way, like this, I'd say this is pointing down right there. This point points down. If you were to rotate it 180 degrees, it would be pointing upwards. Well, the image is still showing that it's pointing downwards, which means right there, it cannot be a rotation either. Okay, so we're going to skip the rotation stuff and dilations, which means that my two transformations should be translations and reflections. So now that I know that, we can proceed. Which one should we do first? As it turns out, it doesn't matter which one you do first. You can choose either one. You can choose a reflection, then a translation. You can choose a translation, then a reflection. I'm going to start with a reflection. So my first one for me is going to be a reflection. Okay, so if I reflect it, where am I going to reflect it? The only options they're going to give us on the assignment are the axes, meaning you're never going to have to reflect it over x equals 4 or y equals -7. None of those types of reflections on these. Only axis reflections. Well, if I wanted this, because I would look at these 2 points right here as pointing to the left, they flip now and they're pointing to the right. See, like this one's pointing down, they're still pointing down, meaning that it has to be a left to right reflection. And the only way we can do that is if the reflection is occurring over the y-axis. So this is my line of reflection right here in blue. And I will reflect all the points. And I will also start with the bottom. very bottom point on figure J, which is right here, -2, -8. So I see that it is 2 to the left, that's 2 boxes to the left of the line of reflection, which means its reflected point will be 2 to the right. So I get this point right here. And I must do this with all the points. So I'm going to go clockwise through this shape, so I'm going to do this one next. And I see that this is 1, 2, 3, 4, 5, 6, 7. 7 boxes to the left of the line of reflection. So I will have to go 1, 2, 3, 4, 5, 6, 7 boxes to the right of the line of reflection in order to get the reflected point right there. Okay, so that's 2 of the 5 points. We got 3 more to go. So I look at the next point here, which is 1, 2, 3, 4, 5, 6 boxes to the left of the line of reflection. So I'd have to go 1, 2, 3, 4, 5, 6 boxes to the right of the line of reflection in order to get its reflected ordered pair. Well, there it is. Now we'll go to the next one. This one right here. So it is 1, 2, 3, 4, 5, 6, 7, 8 boxes to the left of the line of reflection. So I must go 1, 2, 3, 4, 5, 6, 7, 8 boxes to the right of the line of reflection, which gives me this new ordered pair. And then the last one here, this one is 1, 2, 3 boxes to the left, which means I'd have to go 1, 2, 3 boxes to the right of the line of reflection in order to get its reflected image point. So that's all the 5 points. And I can see just the way the points have lined up, and I'm going to draw the lines. I can see just the way the points have lined up right there that it's now in the same shape as figure K. It's in the same orientation as figure K. So let's connect these points then. We got this one. It's not my best, but it's not my worst. Okay, so I have this shape right here, which I've just drawn, and I've got to move it. It appears to be up into figure K. So my reflection was over the y-axis. But now I'm going to make it translate, because I'm just going to move it. Orientation is the same. And I know it's going to be upwards. Okay? So we look at all 5 points and really choose one. I'm going to start with this one here on the right. Okay, so I'm going to start at this rightmost point, and I see it's going to go up, right? Each of the points has to move up the exact same distance. So how far up is that? 1, 2, 3, 4. So I counted 4 boxes. Now, if this is correct, it should be up 4 for all of them. So if I were to look at this point right here, it has gone up 1, 2, 3, 4. And then this point right here as well, it goes up 1, 2, 3, 4. And then this point as well appears to be up 1, 2, 3, 4. And then this final point right here goes up 1, 2, 3, 4. Okay, so they've all moved up 4, which means that the translation is up 4. So when you do this on the assignment, what it will do is it's going to take your, so after you put all this in, at the bottom of the graph, it's going to have the word try. It's going to have a button right there. So you're just going to push that try button, and what it will do is it's going to animate this for you. Now, be careful because the animations are captivating and they may capture your attention so badly that you want to do these over and over and over and become a math nerd. But what it's going to do is it's going to take this shape, the one that we start with, the pre-image, and then it will show that it flips. So that's the reflection. So it's going to show both at one at a time. So it's going to reflect it, and then it's going to move it up. Now, if it's exactly on the image, then it will open up a new question down here. If it doesn't, then it's just going to keep the stuff open, and then you can retry it. So, for example, if I put in up 3, it would reflect this, but it would not go up high enough to make it onto figure K. So you have some wiggle room there on the assignment to make some mistakes, which is good because this takes some time. Now, keep in mind, before we move on to the next part of the question here, is if I were to reverse these, so let's say that I translated this figure J up 4, and then I reflected it over the y-axis, I would have gotten exactly the same shape. So it doesn't matter which of these two that you start with, but it does matter that we know that figure J is the preimage and figure K is the image, because if you had these backwards as figure J is the image and figure K is the preimage, you may have done these in the wrong directions. Okay, so with that, the next part of the question is, it's going to say, are the two shapes congruent? Well, these shapes are congruent. Shapes are congruent. Then it'll say because, well, it's because we only used, and I don't know exactly the wording on the assignment, but we only used, is where we come to that word, rigid. I'm going to say motions. But you could say transformations. Okay, rigid, because reflections and translations maintain congruency. Again, the only reason down here these shapes are congruent because of rigid motions, the only reason they would not be congruent is if they were similar, which means that up here you would have to have had used some kind of dilation, but we didn't. So we only use rigid motions, so they're congruent. So if you ever put non-congruent, you'd say non-rigid motions as well. Determine a series of transformations that would map figure Y onto figure Z. All right. So we have the four types of transformations. Translations, reflections, rotations, and dilations. What I see is that I've got figure Y and figure Z right there, and they're different sizes. Now, right now, just looking at the graph, I don't really care which one is the preimage and the image. We'll get to that. But as of right now, I know for sure that we will be using a dilation at least. Okay. The other thing I notice about these two shapes is that the orientation has not changed. Since the orientation has not changed, then it cannot be a reflection or a rotation. It has to be some kind of translation as well. So this is just going through the four types of transformations that we have and figuring out which of the two that we need to use, because we should only see two on the assignment. All right, and I will go in that order. I'm gonna take this shape, the preimage, and then dilate it first. So again, which of the two is the preimage? Well, it says map figure Y onto figure Z, which makes figure Y our preimage. So I'll start there. And then after, again, we're going to expect two different transformations here. But after the two transformations, we should end up with figure Z, meaning it will be our image, even though it's kind of a double image because we have two different transformations being applied to it. So let's start with a dilation first. And we know that the dilation is going to happen to figure Y, meaning it should get bigger because figure Z is bigger, the image is bigger. So when we look for a scale factor, which we will need, we at least know that the scale factor will be bigger than 1. But we still need to figure out what that is. So, like I was saying before, we do not want to use the diagonal lengths of this shape, either shape, to compare. Otherwise, we need the Pythagorean theorem. Thank goodness then, between the two shapes, we have corresponding parts that are straight, horizontal, or vertical. I'm looking specifically at the vertical side lengths right there, okay? So if I were to compare figure Y, this small red length that I've marked, and I've marked these both in red because they're corresponding side lengths. That side length is 2 boxes tall, which means it's a length of 2. Now again, we would apply a scale factor to that side length to get the bigger side length, which is 1, 2, 3, 4 boxes tall. Now, what we remember, hopefully, is that a factor means that we're going to multiply the values by some factor. Okay, so factor means multiply. So we're going to take the 2 side length and multiply it, because it's a scale factor, by something to get 4. So the question becomes, what do I multiply 2 by to get 4? And the answer to that would be 2. So if I multiply that 2 by 2, I get 4. Now that just clarifies that the scale factor is 2. And if we were to find the lengths of the other side lengths, you would take the length of the preimage, wherever it is, and then you would multiply it by 2 to get the corresponding side length of the image. And as it turns out, we can prove that because I also have this horizontal side length right here on the same triangle right there. So that's 1, 2, 3 boxes in length. And then figure Z right here has 1, 2, 3, 4, 5, 6 boxes, which is what you'd expect because as it turns out, 3 times the 2 would be the 6. Okay, so again, we're just applying the same scale factor to all the side lengths, just the same as we did to all the ordered pairs, all the X's and Y's in the ordered pairs last time in order to dilate a shape. But now we're not just dilating, we have a translation as well as part of this. So I know the scale factor is 2, and now from that, what I need is I have to go through all the ordered pairs and then scale them by a scale factor of 2. So I'm going to start up here. Yeah, I'll start at this point right there. Start at the top. Okay, so that is showing a ordered pair of -3, -1. Okay, so we have -3, down 1. Left 3, down 1 from the origin, which is why it's -3, -1. But it will undergo a scale factor, a dilation with the scale factor, that is 2. Now this will give me a new ordered pair, but all I do is multiply the -3 and the -1 by 2 to get a new X and Y value. So -3 times 2 is -6, -1 times 2 is -2. So I get this ordered pair, which is now the scaled version of this pre-image point. And that would give me the ordered pair, -6, -2, this point right here. Okay, well, there's 1, 2, 3, 4 points. I gotta do with all the points, as it turns out. Okay, so let's go to the next ordered pair. I'm gonna go clockwise to this. So I'm gonna look at this one right here. And that ordered pair appears to be, looks like it's -3, -3. I went left 3, down 3. It's gonna give me -3, -3. And then it's gonna go through a dilation with a scale factor of 2. So -3 times 2, and then -3 times 2. Both of these then are -6. So let's get this point on the graph then. So -6 appears to be right there. And then our next ordered pair right there, it's clockwise. That appears to be at -2, -5. So it will undergo a transformation, specifically a dilation, with the scale factor of 2. So I'm going to multiply those two X and Y values by 2. So that's -2 times 2, which is -4, and -5 times 2, which is -10. So that would give me this ordered pair. We can get -4, -10 on the graph, which appears to be right here. Okay, so this one here is -4, -10. So we have this one on the graph as well. That's 3 of our points. We've got this last one over here on the left corner right there, which appears to be the ordered pair. Let's see, this one is, looks like it's -4, -6, -5, okay. So that ordered pair is at -5, -5. We're going to apply the same dilation of 2 with a scale factor of 2 to both the X and Y value. So this would be -5 times 2, -5 times 2, X and Y respectively would be -10, -10. So this is, again, -10, -10 is our image ordered pair, our first image for figure Y. And -10, -10 is right here, -10, right there. Now that pretty much completes the dilation of figure Y into a new figure. And since we have the points down, let's go ahead and connect the points to make the shape. So it should be the same shape, and it should look pretty much the same. I'm gonna make these transparent so that so it doesn't get too cluttered in here. Now, when I did this with one of the other classes, I accidentally put the point over here because, I don't know, I suck at counting. But in any case, we fixed it, and now you can see that the shape that I've just dilated is exactly the same shape as the one that we need in the very end, figure Z. But we also notice, just like we had before, that we're expecting some kind of translation, which is just to move this shape over. Now I'm not just going to say move, we're going to say translate. So we're going to say now, after a dilation of scale factor of 2, we're going to now translate that figure. I can see that it's going to have to move to the right, and it should be the same amount for all the points. And if we do this for all the points, we should get the same amount. If we find that it's not the same amount, then it's likely that we made the same mistake that I did earlier, where I may have misplaced one of the points, which is okay because we can fix that. But I'm going to start at the top again, just like we did before. I can see that I'm going to have to move this point to the right, which we will have to do. But again, how far? 1, 2, 3, 4, 5. So I'm going to have to move this to the right 5. Now, if we've done this correct, we should have to move it to the right 5 for all the points, which we should. So let's just take a look and make sure that we've done this correct. So this one right here, 1, 2, 3, 4, 5, to the right 5. Same with this green point right here. This is to the right 5, 1, 2, 3, 4, 5. And then this last point right here is going to move to the right, 1, 2, 3, 4, 5. So they're all moving to the right 5, which is good because that means that we did the graphing, at least originally, correct. So once again, when you do this on the computer, it's going to say, hey, it's going to take this shape and it's going to animate this. It's going to expand it, which is going to blow your mind. So it's going to take this and expand it, and then it's going to move it to the right 5, and then you'll be really happy inside. Okay. Now, what may ruin your day after that is that it's going to pull up this next part of the question right here, and it's going to say, well, does that make the shape congruent? And we'd say yes. These two are not congruent. Yeah, not congruent. These are not congruent. Congruent. And again, why are they not congruent? Because the size changed. They went through some kind of dilation. So they're definitely not congruent. And then the second part will say because we used, and again, I don't know the wording exactly on the assignment, but it would say non-rigid, there's that word again, motions. That's what we got to put on there. So again, since we saw that we went through some kind of dilation, we know that these shapes are not going to be congruent, which means we use some non-rigid motion, all right there, okay? Now again, if I had put the wrong number right here, maybe it would have moved it to the right, but then it would have just kept this part. It would not show you the second part of the question. It will not show it until once you push try, then that you've got it correct, okay? And it should end up exactly on the final image that we want. This one right here, we got to determine the series of transformations again. So once again, we also see figure I. Figure I is going to be the pre-image. And then we're going to map it into figure J, which means that figure J must be the image. All right, well, good enough, but from here, we need to figure out which of the transformations we have used. So we only have 4 options, and we have to choose 2 of them. So right here I see between figure I, my pre-image, and figure J, the image, between these two, they're exactly the same size. But the orientation has changed. We'll get to that. But at least seeing that they're the same size means that they're congruent, meaning we could not have used the dilations right here. Now, again, this will take some time to think about, but I've got figure I and figure J. If you were to think about rotating figure I right here, the problem is that this point right here is going to move up over here, but it's not in the same direction. So if I were to take this point and then rotate it, it would be pointed up here, but we see its corresponding point is right there. So in addition to that, it would be a 180-degree rotation, which is not going to work. So I'm going to have to change the orientation, but not with a rotation. I'm going to have to change it at least first, for me, I'm going to change it with a reflection. Now, which way do I reflect it? I don't think it matters. I can reflect it, looks like I probably could reflect it upwards or sideways. I'm going to go sideways on this, though. So I'm going to reflect this over the y-axis. right? Now, we'll see how that's going to help us. So if we do that, then all the points will be the same distance, just in the opposite direction from this line of reflection that we put on there. So I'll start with the point that's closest. So that's 1 point to the left, 1 box to the left, which means its reflection will be 1 box to the right. It will be right here. And I'll do this with all the points. I'll go clockwise again. So I'll go to this point here. That's 1, 2, 3, 4 boxes to the left. So I will go 4 boxes to the right to get its reflected point. And then we'll go to this top point right here, which appears to be 1, 2, 3, 4, 5, 6, 7, 8 boxes to the left. So I will have to go 1, 2, 3, 4, 5, 6, 7, 8 boxes to the right to get its reflection. This point. And then our last point, this point right here, 1, 2, 3, 4, 5, 6 boxes to the left. So we'll have to go 6 boxes to the right, 1, 2, 3, 4, 5, 6. That will give us this point right there. Okay, so I have all those points. All I need now is to connect them to make the shape. And then we can compare it with the with figure J. All right, so that's, again, it's not my best effort, but it's okay. All right, now if you're look at this shape, maybe you'd even think, maybe I can reflect it straight up and down like this. Okay, we can't do that because the orientation still is not good enough. So we did go through a reflection, but what I can see, at least from this shape, is that I can't simply move it, which means right off the bat here, we can get rid of translations. And it wouldn't matter which way you reflected that. So I have to do some form of rotation next. Now, just like we saw last time, all of our rotations are going to be in 90-degree increments. So what I can do is I can take my new image and I can rotate it. All of our rotations as well, just like we've seen before, should rotate about the origin. So I'm going to make a point here at the origin. And I can see just one of the points. I just need to compare one of the points, although you could compare more, and see how far it's been rotated and in which direction. So I will take, I'm going to take kind of this far end point right here, and its corresponding point in figure J is this one. So I've got the 2 purple points marked in addition to the origin here in the middle of the graph, and all I've got to do first is I will take the image point, this first one, and I'll connect this to the center of rotation. And then I will go from the center of rotation to its corresponding point on figure J. Now that should tell us how far it's been rotated. Again, even though my lines are not perfect, what I can see is that it will create this angle. It has to be one 90-degree angle, so that's going to be a 90-degree rotation. And I would say that it's been rotated here. This is in the counterclockwise rotation. Okay, so we now know the rotation, it definitely is, let's say 90-degree counterclockwise rotation. Now, if by chance you were like, you know, this is a 270 degrees clockwise rotation, it's good. But in addition to this, you could have compared any of the points. For example, you could have compared, let's go with these orange points right here like this. Okay, if you were to compare those, you would see as well that by connecting the image point with the final image, that this also would have created a 90-degree counterclockwise rotation right there. Okay, so it doesn't matter which of the points you use. I'm not going to do all 4, but those 2 should be enough to see. It doesn't matter which 2 you use as long as you can see that it's going to be in 90-degree increments. Okay, so we've done this. We've seen that we already mentioned that these 2 are congruent because we have a reflection and a rotation. Last thing we need to do is, because once we do this on the computer, it's going to actually flip it and then rotate it so you can see they are exactly the same. But we know that we have used rigid motions or only transformations that will maintain congruence. So The shapes are congruent. And again, this is because we only used, where they're going to use that word, rigid motions or transformations. And that's it. The figure below is reflected over the x-axis and then rotated 180 degrees counterclockwise. Let's start first with just reflecting it over the x-axis. Then we'll get to our 180 degrees. The direction doesn't matter for 180 degrees. You can go clockwise or counterclockwise. But it says, what are the coordinates of the image of point Y after these transformations? Here's point Y. Here are the other points. I don't care about the other points because it's just saying up here, hey, just look at point Y. Well, thank you very much. Problem. That's going to simplify things for us. And so I look at point Y. Let's start by reflecting that over the x-axis. So the x-axis is the horizontal axis right here. I'm putting in red. That's pretty close. And so reflecting tells me that I've got to take the distance point Y is from my line of reflection, and then it'll be the same distance but in the opposite direction. So point Y, which I have right here, I can see it is down from my line of reflection. Well, how far down? 1, 2, 3, 4, 5, 6 boxes. So I'll have to go 1, 2, 3, 4, 5, 6 boxes up from the line of reflection. And that will be where my new point Y is. I'm going to call it Y prime. Now I can call this Y prime because the individual prime mark tells us that it's gone through one transformation, which in this case is just the reflection over the x-axis. Okay, so that's where Y prime would be our first transformation or reflection over the x-axis. But then it says, hey, go ahead and take this and rotate it 180 degrees clockwise around. It didn't say around the origin, but all of our rotations right now are around the origin. So I will need the ordered pair for this. So that appears to be a -7 and +6. Okay, so if we remember from last time, a 180 degree rotation, if you take your starting ordered pair, which would just be a regular x and y value, and the signs don't matter, after 180 degree rotation, what we're going to do is we're going to keep the x and y's in the same locations, but we take the opposites of those. So it doesn't matter. This is not saying that all of our values are going to be negative. It's just saying take the opposites of these. So let's do that. Let's take our ordered pair that we're starting with, and that's already been reflected. This is Y prime, which is -7, 6. And it's going to go through 180 degree rotation. So that will give us a new ordered pair. So we're going to keep those values where they are, the 7 and the 6, but we're going to take the opposite. So the 7, which was negative, it will now be a +7. That's good. The 6, which was positive, will become a -6. And that would be, I would call that Y double prime. But in actuality, it's just, that's the answer for us. Right there. Now let's look at this. So we got 7, -6, which would have been this ordered pair. 7, -6 is right there. Okay, so why is this 180 degree rotation? Well, as it turns out, if you were to take the center of rotation, which we know is just right in the middle, right there, and if you were to connect the center of rotation with the ordered pair Y prime, it would be the exact same line, but in the opposite direction, almost like a reflection there, in order to get this this ordered pair 7, -6. And that would be 180 degree rotation. Again, this is showing clockwise, but it doesn't really matter which direction you go. 180 degrees clockwise or counterclockwise, doesn't matter. There's our objective for the day. I can use and identify transformations, which is the 4 translations, rotations, reflections, and dilations. Again, we should only use 2 at a time on the figures, and that would be composite transformations.